My second type of equation, this is also in section 3.4, are the equations that involve radicals. So here's my first example. If you have a radical in the equation, what you want to do is get the radical by itself. So the first step is to bring over that minus 6. So we're going to bring that over. So we'll leave the square root of x plus 2 where it is and bring over the minus 6, which makes that a positive 6. My second step is to do powers. So since this is a square root, we can cancel out a square root by raising it to the second power. And so I'm going to raise my 6 to the second power to keep things equivalent. That then simplifies to x plus 2 equal 36. And then I just finish solving that. So when I bring over my 2, I subtract 2 on both sides. I end up getting x equal 34. And then we can check that. My second equation is the fourth root of 2x plus 1 equal 3. And I already have my radical by itself, so I don't have to bring anything over. So I can skip to my second step, which, since this is a fourth root, means I'm going to raise both sides of my equation to the fourth power. So I have 3 to the fourth on the right. Again, the root and the power will cancel one another out, so it just leaves me with what's inside, 2x plus 1, and 3 to the fourth is 81. So now I have a nice, easy equation to solve, so I'll just subtract 1 on both sides, and that leaves me 2x equal 80. And then dividing by 2, I get x to be 40. This equation is a little bit harder because you have this x on the right-hand side. I still begin the same way. I get my radical by itself. So I'm going to leave the square root of x plus 1 on the left side and bring over my 2. So that makes the right side become x minus 2, and I can't combine those. My step 2 is still the same. I'm going to do my powers to cancel out the square root. So since this is a square root, I'm going to square both sides. Now that means I have to do parentheses squared, which means I have to FOIL this out. So I'm going to write this down twice and FOIL this out. You cannot distribute squares, so don't try to do that. You've got to FOIL that out. If I simplify that, that gives me x plus 1 on the left. That part's easy. And if I FOIL out and collect similar terms, I get x squared minus 2x, so that'll be minus 4x, and then plus 4. And this is a little bit harder because I've got the x squared there. So remember, when that happens, you want to get everything on one side. So I'm going to subtract x and subtract 1 to get everything on the same side. And that makes one side 0. That's what I think is easiest to do. So this becomes 0 equal x squared minus 5x plus 3. And I can't factor this one, so I'm going to use the quadratic formula. So a is 1, b is negative 5, and c is 3. And if I put that into the quadratic formula, remember that's x equal negative b, so negative 5, plus or minus the square root of b squared, so negative 5 squared, minus 4ac, so 4 times 1 times 3, all over 2a, so 2 times 1. And I'll simplify that. So it looks like I'm going to get positive 5 plus or minus the square root of, let's see, 25 minus 12 is 13 over 2. And I can't simplify the square root of 13, so this is what I think to be my answer. If you do check that, and I did this in an earlier class and I almost messed up because when I did check, which I should have done all along, the minus one does not work. So my only answer is 5 plus the square root of 13 over 2. So let that be a lesson to you and me. You've got to check these things. This is the hardest kind because you've got 2 radicals in your problem. So what you want to do first is to get the radicals on opposite sides of the equation. So I'm going to bring over my square root of x minus 2, which makes it plus. Okay, so I've put my radicals on opposite sides of the equation. And so that's my first step, is to make sure you get radicals on opposite sides. Now I'm going to do powers. So again, since this is a square root, I'm going to square both sides. And that means that I have to FOIL out this right side. So let me write it down twice, and I may not be able to fit it all in, but I'll put it underneath. So I am going to have to FOIL this out. My left side is just going to simplify easily to 2x plus 3. When I FOIL out the right side, 2 times 2 is 4, and then 2 times the square root of x minus 1, no, 2 times the square root of x minus 2, and then another 2 times the square root of x minus 2. And then when I multiply the last terms together, I just get x minus 2. Combining like terms on the right, 4 minus 2 is 2. And then if I combine my radicals, I just add the coefficients. So 4 times the square root of x minus 2. And then don't forget that x over there. So that's my simplified part. So what I want to do now is to get this radical by itself. So I'm going to subtract 2 and subtract x to get them over to the other side. That gives me x plus 1 equal 4 times the square root of x minus 2. And this is a decision I have to make. If I want to, I can divide by the 4, but that would create fractions. So I think I'm going to leave it on that side, and I'm going to go ahead and square. So I'm going to square both sides. I'm going to, again, have to FOIL this out. So if I FOIL that out, that gives me x squared plus 2x plus 1. And on this side, because this is 4 times x plus 2, I can apply my power to both factors, giving me 16 times x minus 2. And simplifying that side gives me x squared plus 2x plus 1. Distributing that 16 gives me 16x minus 32. Okay, so it looks a little bit better. So what I need to do, because again that's a square, is bring over my 16x and my 32. And that gives me x squared minus 14x plus 33 equals 0. And I can factor that, or I can use the quadratic formula. If I factor it, I get x minus 3 and x minus 11. That's going to give me that negative 14 in the middle. And then remember, we just set that equal to 0. The separate factors equal to 0. And we get x equal 3 and x equal 11. And I checked them both, and they both worked out, but do not forget to check. So that's how you solve radical equations.